storms and hurricanes, devastating droughts and raging forest fires may come only once or twice in our lives, so we think of them as exceptional happenings. But for those plants with much longer lives than ours, such events may be crucial for survival. And those with briefer lives may only be able to exist at all in the aftermath of such disasters. The greatest British hurricane of recent times struck on the night of October the 16th, 1987. Ancient woodlands that had stood for centuries were devastated. For individual trees, like this 250-year-old beech, it was, of course, a catastrophe. But for other plants, it was an opportunity that they had been waiting for decades. The seeds from which these young plants are springing may have come from adults growing in a clearing elsewhere in the wood over a century ago. Since then, they have lain dormant in the soil, but now the light has triggered them into life. They won't have this clearing to themselves for long, so they grow swiftly, and the soil, enriched by rotting woodland leaves, feeds them well. In their second year, they flower. They're foxgloves. The seeds from these flowers will not sprout here. There's no room for them. They will have to find a new clearing, and in their turn may have to wait decades for it. Willow herb competes with the foxgloves for this kind of territory, so it too needs to reproduce urgently. The willow herb seeds, supported by no more than fluff, will be carried in millions far and wide by the wind. After a few years, other claimants appear and contest the ownership of the clearing, young birches. The willow herb may not be able to stay here for much longer. A few years later, the willow herb is gone. The birches, it seems, have won, but the soil is now losing its richness. Most of these birches started their lives about 10 years ago, but there were a lot of them and competition was intense, so most of them didn't do well at all. This one is pretty well dead. This is one of the winners that has overshadowed the rest, but even this one will not be the final holder of this territory. That prize will go to a little seedling like this, an oak. Birches, on the timescale of a wood, have short lives. After 40 or 50 years, they begin to succumb to fungus and disease. Oaks grow more slowly but more strongly. Eventually, they overtake the ailing birches and capture the sunshine. The social struggle in the woodland is over, at least for the time being. The oaks rule. But, as befits ruling monarchs, they have to support a multitude of lesser mortals. The wide-spreading expanses of leaves, all full of starches and sugars, are rich meadows in which vast numbers of creatures can graze throughout the summer. The oaks protect themselves to some degree by generating toxins in their leaves, but that doesn't deter weevils. Or bush crickets. Sawfly larvae munch away within the thickness of the leaves. The caterpillar of the yellow-tailed moth. The Tortrix moth caterpillar converts a leaf into a tube, eats it from within, and then uses it as a shelter while it changes into an adult. The bagworm caterpillar tunnels inside a leaf, but shelters inside a portable tube, which it hangs beneath the leaf which it's currently consuming. The meals the oak provides for these insects then nourish others, when the insects themselves become meals for bigger diners. The great tit with chicks to feed will collect at least 300 caterpillars a day. The banquet only lasts a few months. As summer gives way to autumn, the oaks drop their leaves and halt all activities. And so do their lodgers within their cocoons or hibernating in crevices. As the year turns, sunshine warms the soil, and plants that spent the winter as bulbs below ground race to make use of the light before the oaks can regrow their leaves. First are the snowdrops. As spring proceeds and the sunlight strengthens, bluebells take over. melted blue are a British speciality. 20,000 years ago, glaciers advanced over most of Britain, driving many plant species southwards in front of them. When at last the ice melted, the English Channel began to form and became a barrier that prevented many plants from spreading back from Europe into Britain. The bluebell was one of the few that made it. In the woodlands of North America, things are rather different. These lilies are growing in the Appalachian Mountains. Spring here is even richer than it is in Britain. Instead of just 2 or 3 species of flower in a square yard as you might find in an English woodland, here there are a dozen or even more. Glaciers once covered these mountains too, but no arm of the sea has ever cut them off from the rest of the American continent. So when the glaciers melted, nothing prevented all the spring plants from returning from warmer areas down south. And here, instead of the uniform carpet created by bluebells, there is one with a rich pattern of many colours. Trillium lilies. Dutchman's breeches, wild geranium, a member of the lily family, the bellwort, blue phlox. But the glories of spring do not last long. In April, English oaks rebuild their canopy. The bluebell's time is over. In their few weeks of activity, they manufactured enough food not only to set seed, but below ground to bud off new bulbs. So next spring, if there's room, they will extend their splendid carpet. A young beech reinforces the canopy by adding another lower layer. Shade returns to the woods. In tropical forests, it's never winter, and the trees are in leaf throughout the year. If a plant sitting on the ground beneath such a permanent canopy as this needs sunshine, it will have to climb to get it. These youngsters search for some kind of ladder by lashing around with their whip-like tendrils. Once one of them gets a grip, it puts a coil in the tendril, so shortening it and pulling itself closer to the branch up which it might climb. Other plants ascend by twining their main stem around their support. As the climber gets nearer the canopy and the light, it expands its leaves. There are no more determined competitors in this upward scramble than the rattans that live in the forests of Southeast Asia and tropical Australia. A mature rattan produces the longest stem of any plant. One has been measured at 560 feet. The mature plant doesn't develop leaves on its stem down here on the forest floor. It only does that up in the canopy. This luxuriant growth, basking in the full sunshine 200 feet above the ground, is the crown of the rattan, and it makes the plant's character quite plain. It's a kind of palm. The tendrils with which it climbs are so thin they are easily overlooked, but snag one of these on your arm and it will rip your clothes and your flesh. The tendrils are rigid enough to reach up and hook onto the branches of established trees. They then hold the stouter, heavier main stem in position while it grows upwards from the fearsomely protected bud at its tip. There is, of course, an easier way to get up here. You can float up as a seed. Other plants among these squatters arrived here as seeds stuck to the fur of a monkey or within the gut of a bird. Orchids have seeds that are as fine as dust, so small that they can be lifted by even the faintest breath of air. As a consequence, even the highest branches of the tallest trees may carry spectacular displays of breathtaking blooms. But living up here has its problems. Water must be collected and stored, and away from the ground it's difficult to get mineral nutriment. This orchid deals with those difficulties by wrapping its green roots around the branch it sits on. They then intercept rainwater trickling down the bark that carries with it a trace of nourishing dust. In some forests at higher altitudes there are almost permanent mists, and the canopies of all rainforests get intermittent supplies of water from regular storms. Many plants store water as permanent pools in their centres and have little difficulty in keeping them topped up. Orchids may keep water in swollen bulb-like stems. The ponds in the centre of bromeliads are more than water reservoirs, they're a source of nourishment. Tiny animals such as mosquito larvae take up residence in them, and their excrement and dead bodies accumulate at the bottom as a rich sludge. So the bigger a plant grows, the more food it accumulates. I'm 200 feet above the ground, suspended in the branches of a Kumpasia tree, which is the tallest of all the trees in the Southeast Asian forest. And here beside me is a magnificent basket fern. As it grew and put out leaves, so it collected moisture. And as the leaves got bigger, they in turn collected other leaves falling from above. They decayed to form a rich leaf mould. And as they grew, so more leaves, and with them more seeds, so that now there's a fig tree growing here. So here you have a complete garden, 200 feet up in the forest, with not part of it touching the ground in any way. But some of these squatters can become murderers. A young fig tree like this may arrive here as a seed carried by a bird. At first, it grows quite slowly. As it gains in strength, its roots crawl downwards over its landlord's branches. Some dangle free, but keep on growing. Eventually, they reach the ground. Now, supplied with nutrients from the soil, the fig grows really fast. The rootlets wrapped around the main trunk thicken and fuse into a lattice. The host tree's fate is now sealed, for it is in the clutches of a strangler fig. As years pass, the fig thickens its roots, embracing the trunk ever more completely. Trees grow by increasing their girth. For the host tree, that is now impossible. But growth is difficult anyway, because the fig has a huge crown in the canopy that cuts off sunshine from its host, and its roots in the ground are stealing most of the soil's nutrients. Eventually, the host tree is killed, and its trunk rots away. But the fig does not fall. Its roots now form a hollow cylinder that is quite capable of standing upright by itself. This strangler is about 300 years old. In fact, it may be misleading to refer to it as a single tree. It's probable that 300 years ago there were several young figs up in the canopy. Now, centuries later, their roots have grown down to the ground. They've got rid of the body of their victim, and they're clinging to one another in this extraordinary interlace of pillars and buttresses in order to maintain their dominance of this part of the forest. Nor are these monsters always satisfied with just one victim. This 500-year-old, having strangled its first victim and lost its support, topples sideways into a second, killed that, and then a third, and now its roots are ready to embrace a fourth. Dead tree trunks are not wasted, and neither are dead leaves when they fall. Both are food for fungi. Some leaves are captured even before they reach the ground. The fungus has constructed a net stretched between the twigs of the undergrowth. Once they've caught their leaf, the threads put out white filaments. These produce powerful acid which dissolves the cellulose in the leaves. Why doesn't it dissolve the fungus too? Because fungi are not plants. Their bodies don't contain cellulose. They're constructed instead from a material much more akin to that of which animal horn and hooves are made. Fungi are neither plant nor animal. They belong to a category of life that is all their own. Nourished by the liquefied tissues of leaves, this fungus puts out more threads. But fungi do require moisture. They can only live out in the open like this in the moist atmosphere of the rainforest. In cooler, drier woodlands, they have great difficulty in living out in the open. Instead, they hide in the ground or within the tissues of the bodies they feast on. A fungus has no stem, no root, no leaves. For most of the time, it's nothing more than a tangled tissue of branching threads. These produce digestive acids, absorb the resulting soup, and then use it to construct more threads and widen their search for more dead plant tissue. But cellulose is very low in nitrogen. To get that, some fungi trap living animals. The microscopic threads develop tiny lassos. These give off a chemical that attracts microscopic worms, nematodes. One of them nuzzles into the ring, and the fungus suddenly draws its lasso tight. The worms are killed, and the fungus has its nitrogen. All this takes place out of sight below ground or within the body of a dead plant. Only when a fungus is ready to reproduce does it make itself more visible. From such apparitions as these come spores, the fungal equivalent of seeds. They're so small that they drift away like smoke. But the appearance of these spectacular constructions is brief. As soon as their spores have been shed, sometimes after only a few days, they collapse. Now they are merely food for maggots. So the corpses of plants do not retain their nutriment forever. Some of it is consumed by fungi, and the remainder, now in soluble form, seeps back into the soil to sustain the next generation. But it's not always easy for that new generation to get a start. Here on the northwest coast of America and in British Columbia, fir, spruce and hemlock grow so densely and tall that very little light filters down to the world below, except when one of them dies. This giant tree fell about 10 years ago. The gap it left in the canopy above is still open, but there's still very little light on the forest floor itself. These ferns and mosses are so very thick. But up here on the fallen trunk, things are very different. This is the next generation. Bare bark doesn't hold moisture. Thick moss could bury a seedling. But in moss like this, growing in such a position, a young plant can get all the moisture and the light that it needs. Its thread-like roots grow downwards over the surface of the trunk. Even before they reach the ground, they find plenty of nourishment, from the soil accumulating around the clumps of moss and from the bark that is already being broken down by fungi. Eventually, the roots make contact with the earth, and one after the other, a whole group of vigorous saplings establish themselves along the trunk. So, eventually, a row of giant trees stands in the forest in a line of almost regimental straightness. Each is propped up on arching roots that never were beneath ground, but which still hold between them the rotting remains of the huge trunk that 150 years ago nursed them into life. Southern Australia, in the rolling mountains outside Melbourne. It's drier here than in the American Northwest, but there's still enough rain to support tall forests, and with them a rich, dense undergrowth. These ferns are even taller than the ferns in British Columbia. These are tree ferns, but they're still only understory. Above them rise one of the tallest of all trees. These are called locally mountain ash, but they're no relation of the European ash. In fact, they're eucalypts, and they stand over 300 feet tall. They carry their tiny seeds in small capsules and shed them a few at a time throughout the year. But in the deep shade, the seeds stand no chance. Even if they had landed on the fallen trunk of one of the adults, they would not have been high enough above the ground to be clear of the tree ferns. The fact is that in mature forests like this, the mountain ash has a severe problem of regeneration. The solution could not be more dramatic. It's another of those events that for human beings are major catastrophes. A forest fire. Oil in the bark and leaves of eucalyptus make them extremely inflammable. As the flames leap higher, the seed capsules up in the crowns are singed and they shed their contents. The fire grows in strength and becomes a firestorm. In the wake of such a huge burn, little is left alive. But safe in the soil, below the worst of the heat, many of the eucalyptus seeds have survived. In the sunshine, they sprout with extraordinary speed. Few, if any of their competitors, can match them. Nourished by the rich dressing of ash, They grow around the charred logs as thick and as uniform as a crop of wheat. Within a year or so, they're so tall that no other competitors are able to invade their land. This stump was burning exactly 10 years ago, and these saplings around me sprouted from seeds that germinated immediately after that fire. The saplings are growing so close together that their roots interlock, forming a dense mat into which few other tree seedlings can get a roothold. This land still belongs to the mountain ash. As the trees begin to spread their canopies, the less vigorous saplings are thinned out. Now there is space on the ground for the tree ferns to return. Only the giant redwoods of California exceed the mountain ash in height, and that may only be because of the activities of loggers. Back in the 19th century, one ash was felled here that measured 435 feet. That's the tallest tree ever known. The greatest threat to the survival of this forest is that it should grow for hundreds of years without fire. Should that happen, then these huge trees will eventually die from sheer old age, fall and lie buried among the tree ferns without ever having reseeded. The paradox is that this magnificent forest can only survive if it is first almost destroyed. Another fire, this time in the west of Australia. Here the soil is so poor and the climate so dry that tall trees can't grow. Instead, there's a rich variety of bushy plants. The grass tree has a shock of long leaves that burn fiercely but quickly. It is neither a grass nor a tree, but a strange relation of the lilies. What looks like a woody trunk is a fibrous stem that has a special protection. The grass tree sheds its leaves each year, but their bases remain attached to the stem and produce a thick gum that glues the whole lot together into a very effective fire guard. Even if it doesn't save every one, most will survive. Indeed, every species here has to have the ability to live through at least a brief fire. Otherwise, it would quickly lose its place in the community. It's 8 months since the fire, and the bush has recovered in a most dramatic way. The fire stimulated the various plants in at least 4 different ways. Its sheer heat baked these fruits of the Banksias, opening the windows on the sides and allowing the seeds to fall to the ground. The fire also produced great volumes of ethylene gas, and that triggered the grass tree, after it had regrown its burnt leaves, to put up this huge green spike which will ultimately carry its flowers. The smoke of the fire was the stimulus which caused seeds that had lain dormant in this sand for the last 20 years or so since the last fire. It triggered them to produce the annual plants which are now springing up. And it was the sudden superabundance of nutrients produced by the fire in its ash which allowed the perennial plants like this lovely cat's paw to cover the whole ground with colour. Within a few years, the whole community is fully restored. The fire was an opportunity for the social struggle to begin again. Each individual plant had to fight once more for living space, profiting or suffering from the speed at which it recovered, or its suitability to any slight change in the terrain that the fire created. But overall, the character of the bush remains unchanged. The grasslands of East Africa are not so stable. Here, fire or its absence can trigger great change. This fire is advancing quite fast because the grass is so dry that as soon as the flames get onto a bunch of leaves, they're consumed within seconds. And as long as there's wind behind it, well then it will travel. But in fact, the line of the fire is very thin, and if I want to, it's quite easy to cross it. The land certainly looks ravaged and destroyed, but in fact little damage has been done. The leaves of these grasses certainly have disappeared, but the roots are undamaged. The heat is at its least intense close to the ground, and this part of the root, just close to the surface of the earth, is totally undamaged. And it's from here that the new growth will come. And there are many around to relish the succulent young leaves. Grasses can survive such cropping because their leaves readily break at the base when pulled, leaving the horizontal stems and their buds undamaged. Plants with vertical stems grow from the top. If they are cropped, they're likely to be killed. And if they're pulled, they come up, roots and all. So the great herds of Africa, in effect, weed out the grass's competitors, and it has vast acres to itself, which suits the grazers as well as the grass. But something can upset this happy arrangement, another of those environmental catastrophes. This time, it's drought. The sun turns the soil to dust. The animals, having eaten the last of the dry stalks, move away to look for food elsewhere. The land is left bare. Scavengers come to clean up the corpses of those that starve to death, but they too will soon leave. When the rains at last return, the grass springs again, and so do other plants whose seeds one way or another have landed here. With no animals to graze them, acacia seedlings grow into bushes. And they grow very fast. Once they're a couple of feet high, they're tall enough to survive a quickly moving grass fire, and their thorns will protect them from most grazers. By the time they're about 10 years old, their spreading branches are cutting off most of the light from the ground. Their thrusting roots are sucking up most of the moisture, and the grass has virtually disappeared. A patch of acacia scrub has established itself, and all the trees, significantly, are of the same age and height. They all took the same opportunity to sprout. But this situation isn't permanent either. every elephant that fancies a mouthful of acacia leaves has no problem and no hesitation either in pushing over the whole tree in order to get it. Strangely, it's not just acacias that they knock over. They also push down conifera trees. They don't even like their leaves and seldom eat them. So is that just wanton destruction? Or can they possibly know what the effect of removing the trees will be? Whether they know it or not, a group of elephant, once they've taken up residence in an area, can turn what looked like a promising acacia woodland back to grass in only 4 or 5 years. The grazers return, and the elephants, once more, have supplies of their favourite food, which is grass. Elephants are, without any doubt, prime factors in removing the thorn scrub from the plain and allowing grass to spread. You could argue that in effect they are farming the grass, knocking over trees they don't like and browsing the thorn scrub to destruction. But you could also argue things the other way round. You could maintain that it is the grass which is exploiting the elephants. By providing them with food, year after year, the grass remain the dominant plants on the plains. And if you look at things that way, well then that is a trick which other grasses have played on a worldwide scale. Wheat once grew only around the Mediterranean. 10,000 years ago, its seeds were accepted by a small group of human beings as food. That food was so much to their liking that they sowed the plant wherever they settled and carried it with them as they overran the earth. So, a few species of grass, by recruiting the aid of animals and in particular ourselves, the human animal, have succeeded in interrupting the ecological cycles that have operated for millions of years in so many parts of the earth. They've managed to claim for their own exclusive use not only wide-open plains, but fertile, well-watered lands that once supported rich communities of animals and plants. These grasses have solved the social struggle. They have got rid of their competitors.